Hello everyone, this is Shivam Saxena. So let me introduce my work. So I'm senior network engineer and I have total 5+ years of experience. Currently, I work as SDWAN expert in one of the reputed MNC company. So today we are going to discuss about SDWAN. So let me tell you one thing. Like earlier, Cisco SDWAN was used to call as only Cisco SD-WAN. But now Cisco had changed its naming from Cisco Viptela SD-WAN to Cisco Catalyst SD-WAN. Cisco Catalyst SD-WAN. So now we will, uh, in our entire presentation, we will call it as Cisco Catalyst SD-WAN. And we are going to discuss about uh, this technology. So, what is SD-WAN? Like SD-WAN is a software-defined wide area network. It's a software-defined wide area network. So, if I will start from here by giving the definition and why, from starting like how SD-WAN work and how its components, then you might get bored. That's why I want to make this video very enjoyable so that everyone can understand. So, at first, I want to tell you one thing like why we need anything called SD-WAN. So, for this, we need to go back in the industrial revolution where we used to deploy our network. So, how we used to deploy our network? So, at first, we need to understand this. So, at first, I would like to discuss about traditional WAN. Traditional WAN. So first of all, we will understand this, what is traditional WAN, and later we will discuss about why we need SD-WAN, what challenges we were facing in traditional WAN. Because all you know that um, like necessity is the mother of all inventions. So what kind of necessity we got to know in traditional WAN? Okay, so how we used to design our van earlier. So at first we need to discuss about these things. Okay. So earlier we used to have like we used to connect our sites with the help of MPLS network, and we used to connect our site with the help of internet. Let me write it here. This is MPLS and this is internet. Okay. So suppose that any ABC company, let me draw one diagram so that you can understand the limits. So suppose that we have any company, what name should I give? Suppose that, for example, it's Saxena organization. Okay. So I have one organization called Saxena organization and I have one uh, data center in, let's say, Mumbai. So This is the Mumbai location. Okay. Suppose that this is my router. So here we will only understand how our WAN devices used to connect with other sites. Okay. So this is Mumbai data center. Mumbai data center. This is Mumbai data center router. This is router. And it is connected with MPLS and with internet. Why it is connected with MPLS or internet? Why? Because in order to connect with other sites. Okay. So I'm going to draw other sites as well. So so why I'm connecting this, so that this DC can communicate with other sites, and other sites can have communicate with DC, and they can store their information on Mumbai data center, and they can retrieve some information from the data center. So how they does these things? So they usually do this with the help of their WAN connectivity. Might be they are using MPLS or internet. So let me design here. There might be geographically at different location. So suppose that um, I have one router in uh, Delhi and one in Noida. Okay. So this is Delhi side. Delhi side. And this is Noida side. Now, if Delhi side wants to communicate with data center and Noida side, then we need to connect it from the MPLS or from the internet or from both. Depends on the requirement of the customer. And same goes for Noida side as well. If you want Noida side to communicate with Delhi side and Mumbai data center, so we need to connect it from MPLS and internet. So now in our section organization, we have three three routers, and all routers are in different geographical location. But even though they are in different geographical location, they can communicate with each other with the help of these technologies using MPLS and internet. So in MPLS, at customer premises, we don't need to do anything really. Uh, in terms of for connectivity purpose, we don't need to do anything. All headache goes to the provider edge. It's responsibility of the provider uh, to give us the environment so that we can communicate with each other. At Delhi side, we don't need to create any kind of tunnels. But if we are using internet site as well, so we need to create some kinds of tunnel. Might be we can use IPsec or DMVPN. So this is very basic thing. Everyone know that. So why I'm discussing it here, because I want to let you know what kind of challenges we were facing in this kind of design. Actually, this is the in Saxena organization we have only three sites, but in real scenario it is not actually happen. We usually have multiple sites, might be thousands of sites. So if we have thousands of sites, so it's usually a network administrator overhead to configure each and every device and to monitor each and every device. So if we want to configure if any new sites need to be deployed in any other location, let's say we want to deploy uh, any other site in Bhopal location. So at first we need to uh, configure that router first. Okay, I'm telling you first at configuration side. So we need to configure it manually. Okay, so the manual configuration which will increase the load of the network administrator. And this is the later state I'm telling. But initially stage, what happen if we deploy any site in any new location? So at first we need to check the feasibility of the site to have the MPLS connectivity, because MPLS connectivity cannot be achieved very easily, because suppose that in this Saxena organization might be we are taking MPLS connection from Airtel. So if but if I want to get the MPLS connection in Bhopal location as well, so I want to get the feasibility check done by first itself from the Airtel, whether they have the MPLS connectivity in Bhopal location or not. If they don't have any MPLS connectivity at Bhopal location, so I'll not be able to communicate with the Bhopal location, because um, their Airtel solution is not in the Bhopal location. So this is the first drawback of the MPLS circuit, where we have very uh, like to deploy any sites from in MPLS, to deploy any MPLS site in any new location, it was a very lengthy process, and we need to get it all done. It usually take 2-3 months to get all the things done, to install the routers. Their team will install, if they get connection, so they will install their routers. So feasibility usually take done. So this is the one drawback I've told you. There are multiple drawbacks. So the one drawback is like the feasibility of one telecom service provider must be present to the site where we want to deploy our new site. So this is the first drawback of the traditional network. Another drawback is the traditional network is that uh, the we need to go configure. We need to manually configure the router at the newer site. Suppose that if Saxena organization is very big organization, and it usually have uh, suppose that 60,000 sites. Currently it has 60,000 sites, and day by day suppose that we need to deploy 10 site every day. So it's become very tedious task for network administrator to configure, to go to the site and then configure it manually, because it usually take network administrator also needs to be go to that physical location, and then he will configure the site. So this is the second drawback. uh, Third drawback, after provisioning, third drawback is that monitoring, like if any sites goes down, then at first of all network administrator will not come to know proactively. So this is the third drawback, because in traditional network they don't have any kind of management tool where they can get this information of any if any site goes down or not. Like they don't have any alerting kind of mechanism or event trigger kind of notification in traditional design. SNMP is other thing. If you want to deploy this, then you need to get the tool deploy. So this is the other situation, but I'm talking about the traditional one drawbacks. And the fourth drawback, we can say that right now the world is changing, and the network is also getting changed. How it is getting changed, organization have started migrating their network from on-prem to cloud network. Okay, so uh, if you will see here that in this design, it is very difficult, like not difficult, like you can say it is not ready. It is not ready for the cloud migration, because its design is very its design is centric to data center only. This design, the traditional design, was invented to communicate from one side to the data side. Okay, it was not designed to communicate with hybrid cloud or SaaS application, to communicate with SaaS application. Why I'm saying this? Because in this kind of design, I worked in multiple telecom company, and I have seen that customer usually the customer who is using traditional WAN design. So their traffic was moving to the Mumbai data center only. So if Delhi side wants to communicate to internet as well, if, so the traffic was first to go to the data center, then only it will go to the internet side. Okay, so you can say like why this design was implemented in traditional WAN, because the Saxena organization network engineers don't want to deploy the firewall at each and every sites. So to gain the security of their network, they actually backhaul their traffic to the data center first, and then it goes to the internet. So this is so what is the problem here? The main problem here is the latency. Like the traffic must go to the internet first, but in traditional WAN, it is the traffic is going through the through the Mumbai data center. Okay, so the latency is the main problem. You can see, so slowness issue you can see, and load. You can see how much load is in the Mumbai data center. In Mumbai data center, you need to get how much bandwidth you require in Mumbai data center, because all thousands of sites, the traffic of all thousands of sites will come to this. So you need to plan it accordingly, because Mumbai MPLS circuit is already very expensive, and now you need to any 100 GB uh, MPLS circuit or 1000 GB MPLS circuit here. Why? Just because every sites will send their uh, internet traffic also here. So this is extra burden. So you can say like this is also drawback. So there are also multiple drawbacks you can see like um, okay, let me tell you one drawback as well. Like in MPLS circuit kind of thing, like initially we need to tell our service provider that we want Howden topology or mesh topology. So we have 30,000 sites, and we have already said our service provider that we want Howden topology, and now we have uh, deploy our site with hub and spoke topology. And now if we want to change our topology from hub and spoke to mesh, then it will be a very lengthy process, and it will take around 5 to 6 months at least to change the entire site. Because now what will a provider, your service provider do? He will go to each and every provider is router, and then they will change the hub and spoke topology side by side. It doesn't have any kind of uh, one kind of solution where they can change the topology from hub and spoke to mesh one time. So in traditional network, we don't have such kind of technology. So here, uh, the need that the drawback, this drawback has achieved the attention of IDWAN, and Cisco Catalyst SDWAN is a very good technology which has overcome these all kind of drawbacks and come up with the good situation. Okay, so you have understood like what is the problem in traditional SD-WAN. Now we will discuss how SD-WAN overcome these kind of situations. Uh, okay, so now I'm going to delete it. If anyone wants to copy it, then they can copy it by pausing the video. Okay. And you know what? Why like we have dependency on why we wanted to go to each and every router to perform any kind of monitoring, because each and every router has its own control plane. This is the main problem of traditional WAN. And if each and every router will have their own control plane, which means their brain, you can understand. So the decision will be take place on each and every router. So if we want to change anything, so we earlier we didn't have any kind of centralized approach. We need to go to each and every router to perform the changes. So this is the main problem. Like all of you already know that every router have a control plane and data plane. Okay. So this is what used to happen in a traditional WAN environment. Now what uh, SD-WAN has done is SD-WAN has decoupled the control plane and data plane. What SD-WAN says that now the control plane will not remain in the router. Now the control plane will not remain on each and every sides. Instead, the control plane will remain in any centralized location. Okay, what SD-WAN has done? It has taken this control plane and it has got this control plane in one centralized location. And this centralized location, which we call is in SD-WAN terminal, in Cisco Catalyst SD-WAN terminology, we say this is as a controller. Controller. Okay. Earlier we used to call it as vSmart. Now we call it as a controller. Okay. Now each and every device will have their own data plane only. They won't have their control plane. Okay. So now they can't take any decisions. Their vSmart will going to tell everything. They can't think. They can't do anything. Okay. They can only forward the traffic. Okay. Based on whatever their controller has said. So let me. So this is as per our earlier example. Suppose that this is our Delhi location. Delhi site. Okay. And please adjust with my drawing skills, guys, because our main motto is to understand the concept, not the drawing. And this is Mumbai side. Okay. And suppose that we have deployed our control plane in any centralized location. We can deploy it, or we have multiple options to deploy. Either we can deploy our controller in on-prem, or we can deploy it on in any cloud solutions. So we have multiple options. And this Mumbai site will also have only data plane only. Okay. And suppose that in Mumbai site, we have one site called 10.0.0.0/24. We have one LAN network in Mumbai site. We have another LAN network in Delhi site called 20.0.0.0/24. Okay. Now Mumbai side and Delhi side wants to communicate each other, but Mumbai side and Delhi side doesn't have their control plane. So how they will communicate with each other if Delhi side doesn't have the information of 10.0.0/24 network, and this Mumbai side will also initially doesn't have the knowledge of Delhi side LAN network, which is 20.0.0/24. So here, yeah, you already know we have decoupled, we have extract their control plane and we have put it here. So now their brain is here. And now what will happen in SD-WAN? Each sites share their prefix information with the vSmart. So Delhi side will share their prefix information with the vSmart. Okay, now vSmart has this information. And Mumbai side will also share its prefix information to the vSmart. Okay, they do it with the help of one protocol which we call as OMP, Mobile Management Protocol. Okay, so now every site have shared their prefix information with vSmart. Now it's the responsibility of the vSmart to share each prefix's information to each sites. Okay, so now Delhi site will have the knowledge of 10 network, and Mumbai side will have the knowledge of 20 network as well. Okay, so they do it with the help of mobile management protocol. So actually they don't initially start with the communicating with the SD-WAN controller. Okay, it's not done. Now SD-WAN has some process to follow. Okay, so they have some process. So to understand the process, to understand all the process of SD-WAN, like how vSmart comes, like how everything happens. So I want you guys to please have some patience. Uh, we are going to discuss about each and every components. So please bear with me. Okay. So I'm going to delete it, please. If anyone wants to note, they can note it by pausing the video. I'm going to delete it. Okay. Now we will discuss components of SD-WAN. Components of SD-WAN. It has actually two components. One is you can say controllers, control components, like manager, validator, and controller. Okay, manager earlier we used to call it as vManage, validator is vBond, and controller is vSmart. So this is the first component. Second is the edge devices. Edge devices are V edges and C edges. So Cisco got the Viptela. Okay, Cisco purchased the Viptela product, and now they sell this solution with the name of Cisco Catalyst SDWAN, but earlier it was Viptela SD-WAN. So they also had their hardware devices, which we call. So all Viptela hardware devices are called VHS, and all Cisco devices are called CHS, which support SD-WAN. So it also has some kind of like models like VH 1000, VH 5000, and CHS also has 100, 1000, 4000 series of routers which supports SD-WAN. Okay. Okay. So now I will tell you like how this happened. Like we will understand initialization of this overlay. How this how our SD-WAN overlay is initialized. Okay. So let me draw here one manager. No, it is validator. Validator, manager, controller. Please understand very carefully, guys. Validator, manager, controller, controller. These are our service. Any connections? Might be MPLS or internet. MPLS and internet. And we will have multiple sites over here. Okay, Delhi site, Noida sites, Mumbai sites, and Bhopal sites. Thousands of we can have sites. Delhi site, Mumbai site, Noida site, Bhopal site. Bhopal site is connected to internet. Bhopal site is connected to MPLS as well. Noida site is connected to internet. Noida site is connected to MPLS as well. Mumbai site is connected to internet. Mumbai site is connected to MPLS as well. Delhi site is connected to internet. Delhi site is connected to MPLS as well. These controllers are also connected to MPLS and internet. Okay. Manager is also connected to MPLS. Manager is also connected to internet. Controller is also connected to MPLS. Controller is also connected to internet. Okay. Controller is also connected to internet. What will happen initially? Guys, let me tell you one thing. Like these sites, these routers, Delhi site, this WAN is router. You don't need to configure it anything. You don't need to configure anything. I'm repeating, you don't need to configure anything on this router. If you are using PNP or GTP server, okay. So please listen my words very carefully. You don't need to configure anything on WAN routers if you are using PNP or GTP server. But if you are not using PNP or GTP server, then you need to configure this WAN sites. So I will tell you how we can manually configure these WAN routers if we don't have any GTP or PNP server, or we don't want to use these servers, or for learning purpose we want to understand how we usually configure these WAN routers first. Okay, so initially we configure some basic 5 tuple configuration in each of the vantage devices. So which are mandatory to configure. If those 5 tuples is not configured, then your SD-WAN overlay will not come up. So it is very important to note this thing. Okay. Uh, mandatory 5 tuple configuration which needs to be configured or present on each WAN edge router. ठीक है, to connect with SD-WAN overlay. First one is system IP. Please listen very carefully. First one is system IP. Second is host name. Third, system IP, host name, organization name, organization name. Fourth, V1 IP. And fifth, site ID. So these 5 configuration needs to be present in all SD-WAN router, and if we are using manual configuration, so we need to manually configure it. Okay. So let me tell you what is system IP. Like system IP is same as router ID in OSPF. Okay. So how we used to use router IP in OSPF. So it is same as system IP. This is not routable. It is only for identical purpose in SD-WAN overlay. Hostname, you already know hostname. What is hostname? Hostname is the name of each and every network device. Organization name. Like organization name needs to be unique on all the managed devices. If we have, if this is Saxena organization, then this Saxena organization needs to be present in each and every devices, in controllers as well. Okay, so this should be unique. V1 IP, V1 IP, V1 means validator. So this is the public IP. So the IP of V1 validator needs to be present. Site ID. So let me tell you one thing. Site ID is also site ID is a ID which is assigned to each site. So in Delhi site, we might have one site ID, in Mumbai site 2, Noida 3, Bhopal 4. Okay, so suppose that we have only one router in Delhi site. So this Delhi site will have site ID as 1. And suppose we have 2 routers in Mumbai site. So on both routers, we will have site ID of 2. Okay. So similarly, suppose that in Noida we have 10 vantage devices. So on all vantage devices, we will have same site ID. Okay. So site ID should be same on each side, and it should be unique in each and in when compared to other sites. Okay. It's like it's kind of the site ID concept is very useful. Like suppose that if we have Mumbai side, we have 2 routers. So these 2 routers will have same site ID. So both routers will not form IPsec tunnel with each other because they are in same site. So this is very good practice. Why they will form IPsec tunnel if they belong to same site. So this is a very good thing. Okay. So you have understood these 5 tuples configuration. Suppose that we have configured these this 5-tuple configuration here, and we have injected these cables, and now we have switched on power on these devices. Now what we'll do initially, and we have already configured, suppose that we have already configured controllers. Well, I will tell you how we will configure, but for now, to understand the thing, to understand how initialization process will work, please think that controllers already configured, and we have configured this 5-tuples configuration in each sites, and we have powered on, and all cables are connected. Now what will happen? At first, router will see its V1 IP, validator IP. Now router will try to communicate with validator IP. Okay. If you have given DNS instead of V1 IP, then it will go to the DNS server. But suppose in this case we have given the IP address, the V1 IP address. So that's why I'm saying that that site is directly going to the V1. So initially, this Delhi site will go to the validator, and it will form a DTLS tunnel. Okay. Delhi site will share its information with the validator. Validator will check whether this device is valid or not. Okay. So DTLS tunnel will be formed. It will check its certificates, private public key. If all looks good, then it will then a validator will send IP address of manager and controller to the Delhi site. Now Delhi site have the IP address of manager and controller. Now, and once Delhi site receives the IP address of manager and controller, the DTLS tunnel of validator will be terminated, and now Delhi site will initiate its DTLS connection to the manager. Now it will initiate its DTLS tunnel to the manager, and it will receive with the help of netconf. It will receive its all the configurations with the help of netconf and templates. After that, Delhi site will establish a DTLS tunnel with controller, and once all the control connections are up, then Delhi side will start OMP pairing session with controller, and once OMP pairing will come up, then Delhi side will share its prefix information to the controller, and controller will share all prefixes information to the Delhi sites. Okay, it's kind of BGP. Like how BGP work, like first you need to establish BGP neighborship. Here we have established OMP neighborship. So once OMP neighborship comes up, so this controller has share all prefix information to the Delhi side, and Delhi side has share all prefix information resides in service VPN to the controller. Once Delhi side will have the details of all control all routes. Now it will create IPsec tunnel to each sites. Okay, automatically. You don't need to configure it. You don't need to configure anything. Okay, Delhi side will automatically create IPsec tunnel with each and every sites. This is how our overlay will come up. Okay, so we have understood how our site comes up. Now what remains? Okay, guys, you can note it down. So I'm going to delete it, and now I will share what left. I'm pausing video.